everybody, this is Mrs. Pagan, and in today's lesson we're going to talk about slope and rate of change. So let's go ahead and get started. Alright, so what we say is slope we actually represent as m. So here it is. Slope is represented as with the letter m, and it is rise over run, which also means change in y over the change in x. Now, this is the slope equation we use. I'm going to kind of write it on the side. M equals y2 minus y1 over x2 minus x1, and you actually need 2 points in order to use this, and that's why we label them as the first point with the 1 and the second point with the 2. Alright, so let's really quickly talk about the 4 types of slope that you can see. The first one is a negative slope. So a negative slope is a slope that, it's a negative slope that goes down, okay? And if you think about it, if this is, we read from left to right, so as I'm kind of walking, oh, look, I'm going down, negative slope, okay? An example of a negative slope would be something with negative 2/3. That's a negative slope, and it makes it negative because there's a negative sign right there. Now, a zero slope is a horizontal line. So that's what every zero slope looks like. It's a horizontal line. Usually at Warren, we are walking at a zero slope at all times because our floors are flat. So m equals 0 would be a representation of that. Positive slope is going up. So that's an example of what a positive slope looks like, and you would say m equals 7. It's positive because the number 7 is positive. Undefined slope looks like this. It's a vertical line, and here's how I guess I imagine that there's this little man, and if he was trying to climb this, he'd fall down, and then he would boom, and undefined slope it is. Now, undefined slope happens when we have things like 3 divided by 0. Since the 0 is in the denominator, that makes it undefined. It doesn't necessarily have to be 3. Another example could be negative 2 over 0. Well, anything with the denominator of 0 is undefined. So that's where that concept is coming from. All right, let's go ahead and look at computing slope. So now that we kind of have an idea of what these 4 could possibly look like, right? We want to be able to say, okay, how do you compute it given 2 points? So in example 1a, it says find the slope of the line passing through the points, and then they provide us with 2 points. What I like to do when I have 2 points is I like to label them. For example, if this is my first point, I know that it's x1 and y1 because every point is x comma y, so the ones kind of indicate it's the first point. Then I do x2, y2, just to indicate those. Now, some people like to write them out, and that's okay as well. Then I write slope because I like to know that slope is equal to m. I used to forget that in high school a lot, so I got into the habit of writing slope equals m, which then equals y2 minus y1 over x2 minus x1. And I like to write that out. Now, m equals, and then I substitute in the values. So we know that y2 is 6, so I'm going to do 6. There's a minus sign, so I'm going to bring that down. Then y1 is 0, so I'm going to do that. Divided by x2 is negative 1, so negative 1. There's a minus sign from the equation. Then x1 is negative 3, so negative 3. All right, I'm going to change colors because I see 2 negatives, and 2 negatives create a positive. So technically, I have m equals 6 minus 0 is 6 divided by negative 1 plus 3, which is 2, and therefore the slope is 3. Awesome job. All right, let's try this again. Same concept. We have x1, y1, x2, y2, okay? And once again, we're finding slopes, so I'm going to do what I used to do all throughout high school. Slope equals m, which equals y2 minus y1 over x2 minus x1. It's the change in the y over the change in the x. So m, the slope, equals, and we're going to go ahead and list them. A y sub 2 is negative 1 minus 1. x2 is 5 minus negative 5. Once again, I see two negatives. That doesn't happen often, but sometimes it does. So I like to change them to positive right away. Okay? Because two negatives will multiply and make a positive. M equals negative 1 minus 1 is negative 2. All over 5 plus 5 is 10. I can simplify that, so that simplifies to negative 1 over 5. If I divide this by 2 and divide that by 2. That's what I did in my head really quick to get that slope. So our slope is negative 1/5. Awesome job. Alright. Now let's kind of talk about what if I didn't have the points necessarily, but I just had a graph. Then what I'd like to do is figure out where are the points where it kind of touches the graph that I see are the closest. And sometimes it's hard and sometimes it's easier to see those intersection points. Okay, so I'm going to do my best to find some intersection points where they're going to meet close. Now, this one is really difficult because it's not intersecting exactly where I want it to, but this is pretty close right there. And let's say that there's another intersection happening right there. So then what we would do is the rise over the run. So we know that slope is equal to m, and it's equal to the rise over the run. And what that means is rise is how much are you going up or down, and run is how much are you going to the right and left. Okay, so I'm going to kind of do my rise in red. I'm rising up 1 units to line up with the other point. So since I went up 1, it is positive 1. Now let's kind of check out my run. My run is from that location. I would go 2 units to the right. Well, right is positive, so my run would be 2. So my rise is 1 units up, and my run is 2 units to the right. So my slope is 1/2. All right. Imagine that I have 2 other points. I'm going to kind of put in the points so that so here's one point, let's say, that goes through exactly, and here's another point. So in that case, what we want to do is the same thing. I like to write it out. Slope, I know, is equal to m, and that's equal to the rise, how much I go up or down, over the run, how much I go right and left. Okay. And I always think about, like, when I was a baby, I had to actually stand up, learn how to stand before I can run. So my rise is standing, and my running is running for my mom. All right, so let's kind of look at this. I'm going to go from the first point that I see down, and I went down 1, 2, 3. So I'm actually going negative 3. So my rise is negative 3. I went down 3. And then I want to see how much did I run. Well, I'm going to go 1, 2, 3, 4 to the right, so that's positive 4. So my slope is going to be negative 3/4. Now, I look at this next one and I'm going, wait a minute, that looks like Warren, right? I'm just kind of walking around the hallways, and I'm not doing any work. So the slope here I know is 0. So I know that the slope is actually 0 because it's a horizontal line. But if I didn't know that, right, I can actually use the rise over run method as well. So imagine that I just randomly select 2 points. Here's one of them, here's the other. I would ask myself, how do I get from one point to the other? Well, what's my rise? Rise is 0. So actually I rise 0 because I don't go up or down. But I go over 1, 2, 3 to the right. So I went 0 over 3, and that we know is equal to 0. So that's another way to know, using 2 points, how to find that slope. All right. I hope that was helpful so far. So let's go into this idea of parallel lines and perpendicular lines really quick. All right. We know that parallel lines move in the same direction. And since slope kind of helps us with the direction of the line, we know that a couple things. First, we know parallel lines do not intersect, ever. They don't meet, ever, ever, ever. Okay? And the second thing we know is they move in the same direction. And because they move in the same direction, we can say that they have the same slopes. So if two lines were parallel, then they would have the same slope. So for example, if line 1 has slope equal to 3, okay, then line 2 would have slope of 3. You got it. Okay, so that's what the idea of parallel line means. Now, perpendicular lines are a little bit different. So perpendicular lines actually do intersect. And they intersect at 90 degrees angle. So that's why they are called perpendicular. Like a lot of lines intersect, but when they intersect at 90, they are so special, we give them a special name and we call them perpendicular lines. All right, so these guys move in opposite and reciprocal. I don't think I'm gonna. I think I misspelled that. Okay, so here's what their slopes look like. So they don't have the same slope, they have opposite and reciprocal slopes. Okay, so let me give you an example of that. So for example, if line 1 had a slope of -1/3, then line 2 would have to have a slope of positive, I'm going to write that, 3/1. So the opposite means if one is negative, the other one is positive. And reciprocal means if it's 1/3, then the fraction flips itself to 3/1. So that would be an example of that. All right. Now, I do have a quick task for you. And what I want you to do really quick is I want you to draw a line like this. Okay? You can make it wavy if you want. And I want you to write line 1 here. And I want you to write line 2, okay? Now what I'd like for you to do is I want you to find the slope, aka the m, for line 1 using this point as well as this point, okay? I want you to do the same thing, line slope equals m equals, and then I want you to find the slope of line 2 using the 2 points provided for line 2. So let me highlight those really quick for you. Okay, and what I want you to do is compare them and say, okay, are these lines parallel or are they perpendicular, or is it neither? So if it's not parallel and perpendicular, we say it's neither. All right, give that example a try, and tomorrow in class, that's the first thing we're going to go over. I just want to say you did an awesome job today. I'm very, very proud. So I can't wait to see you in class and talk about this problem with you. Have a great day.